Happy Friday. Welcome back.
We're back.
We're back again. This time we're going to get started. Hopefully this video will be record short for your convenience. We're just going to trust that you know the question, so we will answer the question without telling you what the question was. Sounds good?
All right, so we'll start right off with question 1, part A. This is talking about paternally inherited alleles are silenced. And so in part A, I got for the genotypes, homozygous dominant, 2 heterozygous, 1 homozygous recessive, and for the phenotypes, we're going to have 1 non-disease and 3 with the Angelman disease. And this is simply just because, like we said, the paternal gene is silent, so we're only going to be seeing the maternal genes being expressed here. In part B, we got the genotypes are 2 heterozygous and 2 homozygous recessive, and the phenotypes, all 4 of them have Angelman disease. For C, we got 0 bar bodies, and the reason why we said that is because you have to have a minimum of 2 of the X6 to produce a bar body, and so that's why we got that. Part D, we got 2 bar bodies, and that's because T6 prevents X inactivation from taking place on one of the chromosomes. So without the T6, both would be deactivated.
Great. All right, moving on quickly to number 2. Just going to read them through. A, the gene for that would be SRY, S-R-Y. That is an example of a holorabic gene. B, MYC2 is an example of a gene found on both X and Y chromosome, or it's a sex linked. C, we got a 1-to-1 ratio of normal size mice to dwarf mice. E, we got genomic imprinting and dosage compensation for the 2 blanks, the genomic ones and the fetal ones. F, we got T6 RNA and X6 RNA. And G, first blank is autosomal, and X, and then the next one is X chromosome. Pass it on to you for number 3.
We'll head right along onto number 3.
How can we do this? If you have no music, and just like a screenshot, like.
So for number 3, what we came up with, this is talking about an X-linked recessive disorder. For A, in order to produce the genotype of the woman's mother and father would have been the father, X with a little t and a Y, and then the mother with X big T, X big T.
Yeah.
For B, the chances that the first child would be a son with OTD would be a 25% chance. And if you want, you can take a look at some of our work that we did here, if you can see that. That's kind of grainy, but anyways, moving right along, for C, the genotype of a male with whom the woman could produce a daughter with OTD would be X little t Y. And D, the expected genotypes and phenotypes of the offspring with the mate being the male from the previous section would be the genotypes X big T, X little t, X little t, X little t, X big T and Y, and X little t and Y. And phenotypes would be one unaffected female, one affected female, one unaffected male, and one affected male.
Very good. All right, moving on to number 4. A question irrelevant to BYU Idaho. Question of beards and goats. Fun fact, there are no goats at the Ag Center, so
it's a bummer.
Irrelevant to it. And no beards on campus, so.
No beards anywhere, dang.
Anyways, so A, because the father would be heterozygous, and he would be bearded. The mother would be heterozygous, which should be unbearded. That would produce the offspring in question. Or that would ask the question. B, basically the same thing, because you can see here. So I wrote it out on this one, but in males, these 3 are gonna have beards. And this guy, the recessive guy, is gonna be, or homozygous recessive, is not having a beard. Poor guy, baby-faced goat. And then if you keep the same prodigy, or no, parentage, and you look at the female, you're gonna have the same thing. These 3 are gonna be non-bearded, and now that she's gonna have a beard. Poor girl. So yeah, same answer. Father is heterozygous, bearded. Mother is heterozygous, non-bearded. C. The answer is a homozygous dominant father and heterozygous dominant mother would get you that ratio for the females. And then D, it's going to be heterozygous or homozygous recessive father for beards. He won't have a beard, and his mate will have a beard. Well, no, she'll also not have a beard, but she'll be heterozygous. And that will give you the ratio that you're looking for in there. Going out, Shio, and backwards. Sorry.
So that's just because, for males, that's a dominant trait, and for females, it's a recessive trait. So that's why we see that with the.
Couldn't have said it better myself.
The heterozygotes.
Heterozygotes. Beard goats. Okay. Let's get done with this.
Nice.
Let's keep this under 10 minutes.
Ooh,
yeah.
All right. So for 5, moving right along, we are talking about the cats here. And so we're trying to figure out what we're going to get. Anyways, you can read the question. I'm going to get tongue-tied.
Answer the question.
Yeah. So A, we got the genotypes are X with a big B and X with a little b, X with a little b, X with a b, X with a big B and a Y, X with a little b and a Y. And the phenotypes would be 1 black male, 1 orange male, 1 orange female, 1 tortoiseshell female. For B, we could get a male with a tortoiseshell coat by having an X with a big B, X with a little b, and a Y. And this is an example of the Klinefelter syndrome. For C, when we're talking about the flies, we're just talking about doing some initial crosses and reciprocal crosses. So in question C, we're doing a reciprocal cross for the X-linked chromosomes, or for the X-linked alleles. And so the genotypes that we got with the initial is XB, X big B, X little b, X big B, X little b, XBY, or X big BY, X big BY, Then the phenotypes be 2 unaffected males and 2 unaffected females, so 1-to-1. The reciprocal of that, the genotypes would be X big B, X little b, X little b, X little b, X little by, and X little by, with the phenotypes being 2 affected males and 2 unaffected females. And we see differences in there just because of the X-linked, whatever's. Sorry, I'm tongue-tied today. D.
It's over 10 minutes.
You got this, man.
Sorry.
Damn it. So, D, the genotypes for the initial would be 4 heterozygotes, and the phenotypes would be 4 unaffected progeny, and if we did the reciprocal, we'd come out with the same answer because we're talking about autosomes here instead of X-linked alleles. So there you have it.
Yeah.